Hello, and welcome to episode 5 of our Operate First Espresso series. In the previous two episodes, we went through how to clone a project's repository and manage your notebook's dependencies using some of the Thoth tooling, along with the jupyterlab extensions that are made available to us by our cloud data science working environment. If you've ever tried to use Git to manage and collaborate on Jupyter notebooks, you know just how much of a pain that it can really be. So, in today's episode, I'll demonstrate how we can apply both Git and JupyterLab requirements together to help us more effectively collaborate on data science notebooks and do this in very much the same way that typical software engineers would. So, in our last episode, Isabel created a commit on the Elira DevSecOps tutorial project that's being run by Francesco. The changes that she made were aimed at ultimately improving the model's accuracy. So today, I want to go ahead and review her changes, make a couple of small changes of my own, and then open a PR to the upstream repo where Francesco can review it. This will ultimately result in a contribution to the tutorial from both Isabel and myself. Awesome. So let's get started. I've already gone ahead and forked and cloned the Elira AI DevSecOps tutorial into my JupyterLab environment. So if you're unfamiliar with how to go about this, I encourage you to go back and watch one of our previous episodes. But right now, my repo only knows about my remote fork. So I need to tell it to look for changes in both the upstream repository, the one we originally forked from, as well as to look at Isabel's fork. So I can go ahead and do this quite easily by setting up two additional remote repositories from the terminal that is available in JupyterLab. Let's open up the terminal here. First, I'll move to the correct directory and take a look at the current remote repo that's set up by typing git remote v. Great, and as you can see, we have only one remote at the moment called origin, which points to our fork. In order to add a new remote repository, we need to use the command git remote add and include the name we wish to give the remote, as well as the URL where the repository lives. So let's go over to Isabel's fork on GitHub and copy the remote URL. Now I can go back to my terminal and run the command git remote add Isabel and include this git link. Now I can do the same thing for the upstream repo, copying the remote URL and running the following command: git remote add upstream and the upstream git URL as well. You can name these remotes whatever you like, but it is a pretty standard convention to use origin for yours and upstream for the repo that you forked from and want to contribute back to. Now, if we check our remotes again using git remote v, we can see that we have origin, which of course is my fork and what we started with, as well as Isabel's in the upstream, all set up to communicate with my Jupyter Hub working environment. Awesome. So now that my local repo knows where to look for Isabel's changes, we can go ahead and pull them in and see what she's done. This can be done using the command git fetch Isabel, which will pull her fork's branches into my repository. If we refresh the page and look at the Git UI, we can see that, yes, in fact, her branches have been included. So that's great. Let's go ahead and switch to her branch and see what updates she's made. And we can do this by typing git checkout Isabel master in our terminal. However, you'll see that this will put us in a detached head state, which basically means that any changes that we make here won't actually impact any other branches, which is good at the moment. So let's take a look at what changes she's made in her most recent commit. To do this, we can navigate over to the History tab in the Git UI and expand the most recent commit. Here we can see that only one file was updated, called training.ipynb, which is exactly what we'd expect. And if we click the changes symbol, jupyterlab will display a nicely rendered version of what changes have been made. I really want to pause here for a moment to make it clear just how useful this view on a notebook is. So, if anyone has ever tried to collaborate or review notebooks in the past, you know that they are notoriously tricky to manage. And this is mainly due to the fact that they are not like pure source code in the same way that a .py file is. It's a mix of rendered HTML, JavaScript, as well as Python code, which can result in the underlying diffs looking pretty ugly. So, for example, if I go back to my terminal and I run git diff master and point at the specific training notebook to see what the changes are, it will look something like this. And although it's possible for a human reviewer to parse this and make some sense of it, it's a pain. And the rendered diffs help us focus on the changes that actually matter. So moving back to the notebook, we can see that this commit really only changed the outputs, meaning that it looks like Isabel was most likely just retraining the existing model. It's great. However, we can also see that some of the outputs were removed lower down in the notebook. And in general, I think I think it's good practice for notebooks to display all their cells outputs. So let's go ahead and make that change. Now that I know I'm going to be making some changes that I want to commit later on, let me get rid of this detached head state and convert this branch into a real working branch on my fork. To do that, I will create a new branch and switch over to it. And this can be done using git checkout b new feature. As we can see, and as we can see, we now have a new branch with the same history as Isabel's master branch we were just reviewing. Now I can go ahead and open the notebook and run it myself to generate all the outputs. Since this is a new clone and I don't have the correct kernel on my jupyterlab, I'll go ahead and install the required dependencies defined by the notebook using the requirements extension. And I encourage you all to go back and watch episode 3 with Francesco if you're unsure how to manage your dependencies this way. So once everything's installed, I make sure that I have the correct kernel for my notebook. We can go ahead and restart and run all just to make sure we have a totally clean environment, and then we run all of our cells. And after the training is done and we've run all of our cells, we can see that there's actually is a small bug in this notebook when we try to run all the cells in series. It looks like this notebook assumes that the user already has a remote endpoint set up for object storage. And although this is likely the primary use case for users following along with the tutorial, I don't think that we want to make this a hard requirement to run the notebook successfully. And we want to account for those users that maybe don't have an S3 endpoint set up. So again, I think this is just a good practice to ensure that your notebook's default state or kind of how they exist when they're being shared either through Git or some other mechanism, that they can run completely without error and handle any cases that might require them to rely on external dependencies like a Ceph bucket, for example. Luckily for us, this is a pretty easy fix. We can introduce a new environment variable to set the value based on the use and the development status. So let's go back to the top here and in the notebook, and we can in this environment variable section, we'll add the use Ceph environment variable and do os.getEnv use Ceph and set the default to false in case it's not present in the .m file, and then go ahead and delete the call to it down below. Now let's go ahead and restart and rerun the notebook to generate our outputs. Perfect. We now have an updated notebook that is bug-free in showing all the cells outputs. Now that we've made the changes we want to, let's go ahead and open a PR and see if we can get our contributions added to the upstream project. At this point, if you're unfamiliar with the process of adding and committing your changes, I really encourage you to go ahead and watch our earlier episode where Isabel walked through all of that in detail. But here I will quickly add the training file and a short commit message. And since this is a new branch and I need to make sure that it's tracked on GitHub, we'll have to push from the command line. So I'll go ahead and use git push u origin new feature to push these changes to my remote repository. Success! There's now a new branch on my remote fork that incorporates both of our changes. Now we can go to GitHub and open a PR to the upstream repo. Here we should see a message that a commit was recently pushed and asks if we'd like to open a pull request. Let's go ahead and click compare and pull request. Here we can add a short title and provide a description of the changes we made. This is really helpful for reviewers, in this case Francesco, so he understands the context of the changes we are making. And finally, we can go down to the bottom here and click create pull request. And that's it. That's all we have to do. With our PR submitted, we can now kind of relax, go get some coffee, and wait for Francesco to take a look at our proposed changes. If they are accepted, then they'll be merged into the upstream project's master branch and included in the project moving forward. Great. So yeah, in the next video, Francesco will show you how, with the power of Thoth, we can kind of propagate these changes into a shareable, reproducible, and interactive content image. Thanks for watching. See you next time.